Thanks for having me. My name is Mike Barrett. I'm the Senior Director in the Cloud BU here at Red Hat. I have the privilege of looking after OpenShift, so the core Kubernetes containerization and the layered offerings around that. I run a great product management team. I don't do it by myself. And thinking about this particular presentation, I think I want to talk about what drove the innovation of OpenShift 4 to kick it off, and then get into what we're going to try to deliver in 2021 and into the first half of 2022. So with that, hopefully you can see my big red screen here with OpenShift 2021 Outlook on it, and we'll get started. So, when you take a step back, I don't run into a lot of monoliths anymore. I think we run into a lot of larger applications with a lot of components over a dispersed amount of landscape, right? And although it's been broken up, a lot of that application needs to be updated together. You can't just update a component of it. The whole thing has to be moving in a pretty almost a release train process. And at Red Hat we have products like this, and when I visit customers, they have products like this. It's a very common thing across our industry. And the way it starts out is a normal day, right? You have your client, you have your application, you have transactions going back and forth. And then somebody has a brilliant idea, right? Maybe it's the marketing, the finance group, the outbound. Somebody has a new business feature that they want to implement, and it pulls information out of that application and presents it in a new way, in a great way, in a way that customers will be attracted to. And we make a lot of money off of that. And then somebody realizes, well, what we can probably do is put something in front of all those transactions, and we can start doing some really cool stuff with it. We can augment it with annotations. We can, grab headers. We can insert headers. We can move that information to completely different areas, and we can make more money, and we can go even faster. And so that takes off, and we have all these layers of load balancers, web proxy, EBS, API gateway, whatever it is, it's there, and it's moving information in new ways that weren't possible before. And now we go into that application, we say, look, there's a lot of components in this larger application, and wouldn't it be great if we had some more abstractions inside the application? Let's create some new components that kind of sit in front of maybe the catalog function or the pricing function or whatever these functions are. And we can have all this new information we're filtering hit these particular interfaces. And then somebody says, well, now that we did all that work, we can pull that out. We can make APIs. These things can sit independent of each other, and they can be all around our data center and all around our different investments. And then the pizza box teams, the DevOps, the all that energy comes together, and we can work independently. We can start putting barriers or partitions between these teams, and these teams can function more independently. And then we can modernize them. We can start adding more runtimes that they never really experienced before. Maybe runtimes or maybe even SaaS services at this point we can start mixing in. And then we're told to really do it cheaper. And we're told to look at different cloud platforms that we can run this thing on, and whether it be IBM or Azure or AWS or Google. They all have different techniques and flavors and benefits. And we start having this larger application topology sit across a lot of different infrastructures, which bring a whole set of different requirements that we didn't really think of before. And then somebody says, do it again, and do it again, and do it again. And now I have an entire sort of IT landscape of these things, and they're sitting across a very dispersed investment. And then somebody says, do it everywhere. And that's where we are right now. We're in this phase where we've realized that if we can push this API stack out to where the data first originates, maybe we can even do some more clever things with our industry and with our business. Examples would be, instead of bringing all the raw image from a store that's using cameras to do inventory all the way back to headquarters, maybe we push some neural network information down and put an API stack down there and process those images and only send the results back to headquarters. So there's lots of wonderful possibilities here. Now, what we didn't talk about were all the PCI and HIPAA and SOX and all the firewalls and all the IT best practices, ITSM. There's just a tremendous amount of layers that sits around all these things. How do I connect sort of inside out? How do I do my best practices and connect them out to where all these different API services are running? And that is complex, and that is what we set out to make sure that we were ready to help our customers with OpenShift 4. And that's how you survive. So the first step is you need a commodity platform. You need a platform that has been built on a technology stack that you can find in more and more places. And that isn't just to investment protect you, that's to also just drive energy and innovation and make sure that you're protected and just having, we've seen platforms in the recent past just lose their energy, and now you're trying to figure out how to get off of those platforms. So you want to make sure you're making a safe bet there. We think Kubernetes and the components that we have within Kubernetes really mesh together and bring us that solution. Infrastructure as code, be that Ansible or wherever you're invested in those areas, that is a great investment for you to have. Polyglot, you just heard about the lightweight new Javas. That is extraordinarily important. You need to be able to go in directions of your traditional stacks to the lightweight stacks of Node.js and Quarkus to more heavyweight J2EE type applications. Don't be afraid to leave REST. We have a lot of customers exploring gRPC type topologies now that they're going into serverless and doing a lot of complicated designs. Don't forget about telemetry. This is a huge lesson we learned even within the OpenShift stack ourselves when we were engineering it this time around. You always need that feedback loop on whether or not your application and your endpoint is working the way you think it should be working, and that is telemetry. And there's a lot of amazing lightweight options out there through Prometheus endpoints that is really driving a lot of energy here. Modern CI, we'll get into each one of these, but these are all things that are in OpenShift 4 and that were put there to help you solve that problem that we just clicked through. So let's get into the solution. OpenShift has gotten a lot bigger over the last 2 years, and we're not even only on RHEL anymore. We do have window nodes and alternative runtimes in there. But going across the bottom, we have a lot of energy of multi-arch with Power and Z and ARM, hopefully coming at the end of this year. We have on the cluster services itself, there's a lot of people that want to take the lessons learned from Service Mesh and just have a stripped down Envoy that you can use more as an ingress controller in your data center. So there's a lot of cool stuff happening there. On platform services, you have Server Mesh and Serverless coming together around a developer experience, and we have data services. And on top of that, you have compliance, configuration, and policy. So there's a great stack here, and if you haven't experienced all of it, definitely dive in with us. We're here to help lead you. So where is 2021 going, and why is it going there? The first is enabling a hybrid cloud, and this is where you see us spending a tremendous amount of energy going back to the platforms that we run on and adding platforms. So take, for example, AWS. We obviously run on AWS. We have our IPI, fully automated installation, where we carve what we need out of AWS, and we also have a more manual install where you get to decide the components of AWS you want to bring up and have us install on top of. Where we made some design leaps is we thought customers would want us to make the experience as agnostic as possible. So drive to a commonality across AWS and GCP and Azure and IBM public cloud. What we're finding in this last year is that customers want to dive in deeper to each of those clouds. So they want to get into exactly how AWS does short-lived tokens, for example, on their AIM roles. And that's unique to just AWS and not the same implementation on Azure. And you'll see the same discrepancies at every layer of that stack, be it ingress or be the storage techniques now that they're getting more advanced. So we're going back in there and we're making sure that we can shine a light on those investment areas that you may be more interested in benefiting from. And that's a lot of work that's happening in 2021. Around workloads, we spent a lot of time bringing a lot of stateful services into the platform last year. So if you look in the operator catalog, you'll notice there's probably over 20 database-like services, be that caching or no SQL or SQL, whatever the case may be. There's quite a mix in the operator hub and in the Red Hat marketplace for you there. And that didn't happen by accident. That was a very focused initiative that we had. Now this year, we're going to try to get more SaaS services involved. So we have this concept of a SaaS operator where you have a custom resource definition run on the cluster. It calls out to whatever services that you want and helps maintain that connection for you. And then you do the service binding into your application. So you'll see a lot more of that this year. And obviously, AI isn't going anywhere. So we will focus on AI as well. On the developer experience, it's really a new stack that has been born. And this happens probably every 2 to 3 years that enough energy occurs around some open source projects and they start talking to each other and bam, something's born. And I'll take you through what that looks like this year. And then on the management and automation, we have the advanced cluster management solution. We were lucky enough to acquire into Red Hat an IBM engineering team that was working on multi-cluster initiatives. So we were able to really bring this to market quickly. And it's a great solution. If you haven't seen it before, it drives a lot of eventing, a lot of compliance, a lot of keeping clusters exactly the same. And obviously the Ansible solution connects to that very well. These features are because of these customers and more customers like them. So over 1,700, over 2,000 at this point, customers using OpenShift in a variety of different ways. There are groupings where you see common patterns across them, and we're this year going to try to get them to come together and talk a lot about how they're using it, just like you heard earlier today. But there's obviously modernization happening. There's cloud native development that's sort of evolving into serverless and sort of event-driven computing. And there's intelligent applications that are connected to that. And then there's this push to this edge use case, which everybody is excited about. And obviously nobody has just one cluster anymore. This was a sort of a surprise to us at Red Hat. We were able to partner with the cloud vendors, and the cloud vendors wanted to maintain both their cloud offerings around Kubernetes, but also add offerings for OpenShift where they themselves will treat it as one of their products. One of their products in their catalogs, one of their products in their sort of financial system, one of their products in how they SRE it and sort of have us as their backline. And that's happened with AWS, and that's happened with Microsoft, and that's happened with IBM. And it's a great way to experience OpenShift on multiple different clouds. We will obviously maintain our OpenShift dedicated, but we see a lot of customers mixing and matching the managed service offerings of OpenShift with their standard on-premises OCP. And now the vendors want to come into your data center and help run your on-premises OCP. And you see IBM Cloud Satellite doing that next quarter. I think they're launching. What we're doing to sort of help this, like I mentioned before, where you see us driving a less agnostic platform and trying to make sure that the reason you chose AWS or Azure or IBM or Google was for the services or for the way they implement their infrastructure. And we want to make sure you're getting the benefit of those clouds. So you see a lot of that work. You see us rounding out some more boutique clouds. And you have us paying more attention to our Asia Pacific region. There's a lot of business in that area of the world, and they have very particular cloud requirements, and you see us partnering in that area this year. We also, 2020 was a great learning year for us in how people are using these public clouds. There's maybe not more than every 10 that are exactly alike in how people are blending all the VPCs and private link and different implementations in different ways with their ingress and their own DNS. There's just a lot of complexity around solutions from customers, and there's reasons why they're doing it that way. So getting OpenShift to sort of morph and accept those different deployment patterns, that is a lot of work, and you'll see us doing that this year as well. Now moving into the infrastructure stack. We talked about running anywhere in the cloud. What if you wanted to maybe this year move some application services that you never thought would be in a container and will just stay in a virtual machine? And maybe you have some latency requirements or some GPUs or some reason to be on bare metal. We have a lot of customers. I would say at least 80% of our customer base has at least one investment in a bare metal cluster. They're obviously invested in public clouds and invested in virtualization layers, but just about almost everybody, the majority of them, have an investment in a bare metal environment. And so we needed to drive there with our customers. And you see us taking a lot of our OpenStack knowledge and bringing it into OpenShift. And that started with the Metal Cubed project, where we were able to take OpenStack ironic APIs, sort of codify them in a CRD in Kubernetes language, and then use that API as if it's a cloud API. So when I'm asking for a machine, I can ask that API for a machine, and it'll go talk to the Redfish service processor on that particular server and bring up that rack. So a lot of amazing innovation in those areas. And then we have KubeVirt, which is an amazing project, and that allows us to really take virtual machines into the application more aggressively, where before, obviously, you were mixing virtual machines and containers, but maybe they weren't sharing the same ingress, and maybe they weren't sharing the same scheduler around adding CPU or memory to it, and maybe they weren't having the same role-based access and the same user experience for the administration staff. And now with KubeVirt, we do have that ability to integrate them more aggressively. And that is KubeVirt. The other thing that is occurring in this area is alternative container runtimes. And this is not to say at all that a Linux container is unsafe or insecure in any way, shape, or form. There's a huge technology stack around Linux containers that makes them safe and allowable for multi-tenancy. There are, however, applications and certain areas where you might want to deploy an application that has different auditing requirements, where you need something that's more like a virtual machine. And maybe you don't want to go all the way to a virtual machine with KubeVirt. That's where Kata containers come in this year. And Kata containers gives you a lightweight KVM implementation that's more feels like a container, in that you can take your existing container images, your OCI compliant container images, and you can run them on this alternative runtime. And so you can accelerate your growth and use of that platform in new use cases. Windows containers, speaking of new use cases, this took a while to bake in the upstream, right? And it's still baking in the upstream. Some of the really core components of it will come in Kubernetes 1.23 when they start solving some of the resource allocation and isolation issues, and they sort of switched on Windows to a Container D implementation. Right now, Microsoft is on a Docker implementation in that operating system. But with Windows containers, you do have an ability to target, you need to be careful. You don't want to re-instrument all your Windows applications out there. And if you are re-instrumenting it, you probably should re-instrument all the way to a .NET Core. So there's this nice slice in between that this is perfect for. And this is grabbing some framework, some .NET framework, some .NET Legacy, maybe the 3.x and 4.x range of .NET, and bring those applications over. And we have a lot of customers that are moving pretty aggressively in that particular direction. I mentioned advanced cluster management before. The concept here, we spent probably 2017, 2018 trying to get the entire community of Kubernetes to come together around a multi-cluster solution. And we were working in a lot of SIGs around multi-cluster. Federation was a concept. And what most vendors end up doing, and you see, Anthos, and you see Tanzu, and you see Arc, and you see Advanced Cluster Management, all these things have a commonality in that they deploy something, a CRD, into a different cluster, right? Into an EKS, AKS, GKE, OpenShift, whatever the case may be. And this, in our vocabulary, this is a clusterlet. And this clusterlet then connects to a control plane that's running somewhere, and that control plane allows you to look across all your clusterlets and start doing really incredible things. You can open up a shell and you can ask it, show me the YAML for this particular application everywhere. You can label your applications, and the clusterlets will talk and make sure that if prod one label isn't on one of these web services, then that cluster is out of compliance and you need to deploy a new sort of application with that label. So there's simple primitives that you can build on, and you can have this amazing automated platform for all of your clusters, not even just your OpenShift clusters, but all of your Kubernetes investments with this solution. So something that's really you should take some time and investigate if you haven't. Now, this is what I was alluding to before, and this is the new developer stack. So it's hard to say where it started. For us, it started with a purchase of CodeEnvy, and with CodeEnvy, we brought in this Code Ready project. Pretty much around that same time, we saw service mesh kind of explode. And the reason why service mesh is exploding is when you look at that distributed monster and all those data centers running those API-driven solutions, you're going to run into situations where you, as the application owner, need to make some business decisions with those APIs. For example, you could say that you're selling, I don't know, albums, CDs, and you can see that the price of a CD is $4, but you don't know how many CDs you have in stock. You need to make a decision on whether you're going to allow that sort of function to move forward and take that purchase, or if you're going to block that API call. And so you can start putting a lot of these circuit breakers and different pooling mechanisms into your class paths, and in with that service mesh, you can drive a lot of functionality. And so because of that, developers need these solutions on their tool, right? They need an understanding of a layer 7 that they can pull into their applications. He or she needs to understand that there is a serverless layer on top where you don't have to deal with individual runtimes and you can stay in your code. They don't have to call out anymore to legacy CI/CD systems. They can run a lightweight solution that is basically another custom resource definition within Kubernetes that allows you to do more task-based testing of your applications as they run, and that's Tekton. And you can call out to GitHub through actions or through different automation techniques. You don't have to use our source to image anymore. There's an extensible interface in Kubernetes now that allows you to use build packs or Builder or whatever the case may be, something that you're interested in. You can establish pipelines of pipelines. Like you can have multiple reasons to deploy to multiple clusters, to deploy to multiple CI/CD paths for yourself, and that's Argo. You can package things in either operators or Helm. We give you both choices today, and you can add those telemetry endpoints to whatever you're doing with Prometheus. And at the end of the day, you do have an ability now to code and debug with dependency checking into a build and package environment, into a run environment, and all the way out to a deployment across any infrastructure that you might be on. And those tools come out of the box ready to work in a Kubernetes native way. And that's something that's extraordinarily powerful for us this year, and we have a lot of customers that are driving us in those areas. I mentioned serverless and serverless mesh. Service mesh is really going to focus on multi-cluster meshes this year. So adding this SDOD, making it more centralized and having it have an understanding of different labels across different clusters. And then on the serverless side, you see we really are strengthening our event processing. So it took us a while to GA eventing in serverless. Now that it's out there, we have Kafka. You'll see more events come in and more integration scenarios for you. Edge is huge for us. When you look at this, it's not just an OpenShift technology. As you have your core, you have what you know today has OpenShift. And then as you start moving to the left of the screen, you have really different form factors that you need to fit in. But not only the form factors, you have different technologies at play at the networking layer, at the latency, at the heartbeat, at the am I alive? You need some autonomy out there. You need to protect against split brains, somebody going down and somebody else restarting that service, and then that other person coming back alive and running over that other service. So there's a lot of techniques that we're investing in this year that really allow you to push this out towards where the data is being born. The edge. Everybody wants an intelligent application, and everybody has a right to an intelligent application, whether that's a decision tree with maybe Scikit, or if that's TensorFlow with a neural network looking at images, or whether it's PyTorch. Everybody should be able to be successful with that stack, and everybody should be able to have a pipeline for that stack and a developer experience around that, blending their traditional runtimes like Node.js and Quarkus with those other technologies. And there's a pattern, there's a deployment pattern called Open Data Hub that Red Hat champions, that is a mix of different vendor solutions and different open source technologies. And if you haven't seen it, definitely check it out. And with that, we have that ecosystem. And that ecosystem, this is pretty much the $34 billion reason why Red Hat was acquired. I think everybody understands today how to use different cloud infrastructures. They understand instance types. They understand network, ingress, load balancers, EBS storage compared to pdisk storage. Those are common things. Where people are less secure in their knowledge is all of the SaaS services on every single cloud, and how do I blend those in, and then how do I blend them in with my over-the-counter ISV ecosystem that is going to be there for me, and then how do I build my own tooling and my own APIs to integrate with all of this rich application services. And that's OpenShift that sits in and that's where we want to be. So wrapping up, this is the next 24 months for us. We have a lot of these cloud vendors coming on premises, doing a more hybrid technique, and that's a lot of engineering work that we need to roll up our sleeves on. Driving out to the edge, picking up those KubeVirt, Kata container, high performance networking. There's a lot of complex things that when you start talking to hardware and start talking to NUMA topologies for CPUs, that we need to engineer into Kubernetes. So that layer is solid. Networking and routing is going to sort of explode. You have the Ingress version 2 that went stable in Kubernetes just recently. So a lot of projects like Contour and other ones mixing with traditional sort of 3-scale or API gateway solutions, and then merging that in with a service mesh out of the box. You see a lot of energy in those areas. And then sophistication around problem detection and vertical scaling instead of horizontal scaling, complex scheduling algorithms, more density, more observability, moving up the stack to cert lifecycle and vault patterns, and then AI toolkits and Kafka and gRPC and Quarkus, and then multi-cluster management. On the far right, I do want to make a point. There's a lot of benefits this year in 2021 of connecting back to Red Hat. Just like you, when you deploy your APIs and you need lightweight telemetry to tell if your application is working well, we did the same with OpenShift 4. It is in no way us eavesdropping on you. We're just making sure that the product works well. And what drove us in this area is being compared to a lot of SaaS services where the vendor may be taking care of things for you. We are now taking care of things for you without you knowing. And the way that vocalizes itself is we have an ability to patch OpenShift pretty aggressively without you opening up a service call. So if we see problems, we can just send out patches for problems without customers going through that heartburn of opening cases and then generating a fix for everything. That'll still happen. It just doesn't have to happen for everything. And in 2020, we released probably about 120 fixes that were of that character. So the product is definitely organically is solving itself.